Hello, my name is Paul Boland, and for my mechatronics project, I decided to analyze my record player. The record player is a unique system that transforms mechanical movement into electrical signals and then into audio. The record player has four main components: the needle, the arm, a rotating base, and speakers. Here's a simplified schematic of the record player arm, needle, base assembly. The record player works by converting the small movements of the arm and the record grooves into electrical signals. Let's take a closer look at the arm assembly. Here is a top view of a simplified arm and needle schematic with the arm in blue and the needle in orange. The needle on an actual record player is very small and usually has a diamond tip such that it does not easily wear. The needle follows along in the many grooves that are present in the record itself. A close-up of these grooves shows their general shape. Take note that the grooves are the same depth yet vary side to side. This will cause the needle and arm to oscillate back and forth as it follows the grooves. Now back to the schematic. On the end of the arm is a permanent magnet. Around this magnet is a housing. On either side of the housing there are coils of wire. The front of the housing is responsible for suspending the arm such that as the arm oscillates, the magnet on the back of the arm oscillates with it. Now, according to Faraday's law, a change in magnetic flux seen by a coil of wire can induce a voltage in that coil of wire. Since flux is a function of the magnetic field, this means that as the magnet oscillates between the two coils, a changing voltage will be induced into the coils. The two coils correspond to the two speakers, with the current from the left coil going to the left speaker and the current from the right coil going to the right speaker. Now a few observations can be made to help understand why the movement of the magnet creates a changing magnetic flux. From an observation, it is evident that the magnetic field of a permanent magnet is strongest closest to the surface of the magnet. If we define our terms as shown, we can draw a few conclusions. First is that the strength of the magnetic field seen by the magnet is proportional to the position of the magnet. This just means as the magnet gets closer to the coil, the strength of the magnetic field experienced by the coil increases. The second conclusion comes from the definition of magnetic flux, that the flux is proportional to the strength of the magnetic field. From these two conclusions, we can then conclude that the position of the magnet with respect to the coil is proportional to the magnetic flux seen by the coil. We can even take this one step further by differentiating both sides, and then we can see that the velocity of the magnet's oscillations is proportional to the induced voltage in the coil. Using Simulink, we can simulate a plot for the induced EMF. Since the oscillations of the needle are very sporadic, we can simulate the magnetic flux seen by the coil using a random number generator. By taking a derivative of this input, we get the induced voltage. We can plot the input versus the response, and we can see that we get our oscillating voltage signal. Now the dilemma occurs that we still need to convert this signal into sound waves so that the record can be listened to. This is where the speaker comes in. The speaker consists of a few main components. First, a coil of wire that the current induced from the coil in the arm will pass through. Second, a magnet that is positioned below this coil. Third, a general frame that holds the components. And finally, a cone or diaphragm that is connected to the coil. As current flows through the coil of wire, a magnetic field is induced. A visualization of this magnetic field can be seen in this figure. Therefore, as the current flows in and out of this coil, the magnetic field that is created will attract and repel the magnet below, causing the coil assembly to oscillate. As the coil assembly oscillates, it will vibrate the diaphragm. The diaphragm is constructed in such a way that these vibrations can be heard as sound. A few extra interesting features of my record player include position sensors that automatically start and stop the rotating base that is responsible for turning the record. These sensors are correlated to the horizontal angle of the arm and can be seen here in operation. These sensors are useful for helping prevent excessive wear of the needle when the record is finished playing. Here's a list of my sources for some of the pictures I used in my presentation. Thank you for watching my presentation on record players.